we're going to see how iMachining combined with simultaneous 5-axis helps us to machine this impeller. Generally, the impellers are done using a different process from what you're going to see today, especially the roughing. The first portion of the part is turned, and what is turned basically is this particular profile. This profile is completely turned. It's either turned on regular 2-axis lathe, or even in some cases these are milled on 3-axis machines. But today we're going to see, because this particular, let's say, customer ABC has only one machine, and that's a 5-axis machine, and he doesn't want to cut in 3-axis and then do 5-axis roughing. He wants to challenge, he wants to improve his productivity by cutting down on this roughing time and finishing time of this particular area, and then machine the entire impeller blades using simultaneous 5-axis. Right, so what we have today, to start off with, I've used a Hermle C30 machine on which this part is going to be cut on, and we have the impeller model and a fixture that's going to hold this. And this is a pretty nice kind of a fixture. It's a positive holding. It has got extremely very rigid holding, and my machine is also pretty new, so I could really be aggressive in my cutting parameters. So what I have done today is I have selected Hermle as my machine, and we have used 16 mm CR5 material to cut this part. 16 mm CR5 has a ultimate tensile strength of about 680 megapascals, and there's a new feature that's come up in SolidCAM 2014, and that's the machinability factor. Many times when you take up a particular UTS, or the ultimate tensile strength, SolidCAM generates a host of cutting conditions in iMachining, and then you pick one of those cutting conditions and take it to the machine, and then you realize that this material looks to be much harder than what its ultimate tensile strength indicates. Or it could be the other way around. You take that to the machine and you realize when it starts cutting, this material looks much softer than what the ultimate tensile strength actually indicates. In such case, if it is appearing softer, we will push the machinability factor to the positive side. The positive side, when I push it, my parameters or my cutting conditions immediately or dynamically change. On the other hand, if the material appears to be harder, then I push it on the negative side. This basically will tell to the system that this particular material is much tough to cut than what the UTS is indicating. So it will readjust the parameters accordingly, or the cutting conditions accordingly. I'm going to put it back to 0 and save and exit. We're going to use level 8, so it's the most aggressive level of cutting. Towards the end of this webinar, I will show you a video of the same part using the same fixtures on a Hermle C30 being cut. So you will get a better idea of what this whole thing looks like. All right, so I'm going to accept this. And what we have today is we're going to use a 16 millimeter end mill from Hoffman, and we're going to cut this part. So let me add iMachining 3D. Okay. Tool, I'm going to pick the end mill. This is a 16 millimeter end mill. It's using a well-done shank, a well-done holder rather. It's 5 flutes. This is actually a tool from Hoffman. Okay. Let's select this tool. It's 48 millimeters. Its cutting length. Levels. My lower level is actually not that, but my lower level is somewhere on this fillet, and I will give another delta value of about -2, so that I'm going to push that down to -42.247. Okay. We have defined the material machine. We have the geometry here. We have picked the tool, levels, and then SolidCAM immediately has calculated the cutting condition for me. At level 8, which is really the most aggressive level that we can have in the regular iMachining, not the turbo, it's calculated an RPM of 5,742, a feed rate of 7.3 meters, a maximum step over of 0.87, a minimum step over of 0.12. Corresponds to a VC of 289 and a mean chip thickness of 0.11 with a maximum cutting angle of 27 degrees and a minimum cutting angle of 10 degrees. Now, out of the 15 kilowatt that the machine has on its spindle, it's going to use only 8.3 kilowatt on this cut, which is almost like 50%. Okay, now if you look back at the tool, this is a special grade from Hoffman. It's the premium carbide, or what we call as the ultra-fine carbide. Basically, you have two grades. We have the normal carbide, where the grains are of normal size, and then there is a fine grade, where the grains of carbide are really very small, much thinner than the regular carbide. In such cases, when the binding of the carbide is much better, the parameters can go as high as 150% of the regular carbide. So this is what this is what iMachining does. It allows you to pick the type of material of the tool. So if I pick premium carbide, it jumps up to 150%. All right. So we have selected this. We have selected our level. Parameters are calculated automatically. Let's go to the technology. I would like to keep about 0.4 millimeter on these walls, and a tool path tolerance of about 4 microns, doesn't matter. Right, and we just need to change our arc size. Since we're using a 8 diameter cutter, I'll get it close to 8 millimeters. Okay, that should be good enough. Okay. And then we have a new thing coming up again in iMachining, and that's called as a constant chip thickness control for arcs. Generally what happens in iMachining is it keeps the feed rate almost constant when it's going over the arc, because it generates the pattern in such a way that the chip thickness is tried to maintain constant even when going over arcs, especially the corners. This particular slider here allows us to decrease the feed rates when it is going over arcs to match certain machines, because certain machines it is virtually not possible for it to travel at the same feed rates when it is going over the arc. Thereby, what happens is feed rate drops and the chip thickness increases. Thereby, it affects the tool life. We can actually pull down the slider and actually reduce the feed rate over arcs. This makes it easier for machines, especially the older ones, which can't go at the same feed rate over the arc. It tries to maintain lower feed rates when moving over the arc. All right, this is a new machine, so it doesn't have any such issues. Let me save this, and let's hit the calculate button. This could take about 40 seconds. Okay, the calculation is done. Let's look at how the toolpath looks like. Nice. So that's how the toolpath looks like. Let's run the simulation on Solid Verify. So that's how my stock looks like, along with these fixture components. Okay, let's zoom in so that you can see it much better. Okay, there we go. It's taken about 40 millimeters at one go, and then it is generating the scallops. This is used as the step-up technology of iMachining. Since the scallop is pretty high, you can see the staircases coming up. Else you would have seen a very fine scallop. The scallop is pretty high. It's about 2.6 millimeters, so it's creating those staircase kind of an effect. All right, so in about 12 minutes, it has roughed out this part. Sometimes it looks like it's even faster than turning it. So we can actually do straight away iMachining 3D, and that it's ready for machining. All right. So once we have the roughing done, let's move to the next toolpath. These are basically 5-axis toolpaths. So I'm going to start with the roughing of this blade area here. So for that, I'm going to use the multi-blade machining. Now this is a module inside SolidCAM. It's a special module inside SolidCAM, or rather it's an application-based module which is meant only to cut impellers. It doesn't matter what kind of an impeller, but it is meant to cut only impellers. So what you have, very simple interface. We have first a strategy. We have 3 strategies: offset from hub, offset from shroud, offset from hub and shroud. Now, because this is an impeller, if you can look at the blades, the length of the blade on the trailing edge and the length of the width of the blade here is different. The width of the blade on the leading edge is much bigger than the width here. So if I use morphing between the hub and the shroud, I will have several passes which will actually cut nicely here, but when they come back on this side, they are actually going to rub. They're not going to do anything because of the morphing technique. So, which means that I might end up having a problem or having lower tool life because it's just rubbing. So what I'm going to do is I'm going to use a different kind of a technique this time. I will use offset from the hub that is parallel to this particular surface. Okay. In such cases, we will not have the issue of tool rubbing because the distribution of cuts will be according to this particular surface. All right, so we're going to pick the first set of surfaces. Okay, those are the surfaces, which is basically the blades, main blades, and the splitter, including the fillets. So I will click OK, and I will leave a stock of about 50 microns. On the hub, I would like to pick this surface up here. Okay, select OK. Maybe 50 microns also on this side. Let's go to the tool. I'll select a Hoffman 6mm taper ball nose. This is how it's going to look like. Okay, so we're using the shortest possible tool for roughing. It allows us to be more aggressive with our parameters when you use a shorter tool. on the spear, on the clearance, we're using a spear. Now this is by default, or it's directly from the system. It'll auto detect the position and the dimension. The toolpath parameters in the technology, I would like to have a maximum of 15 cuts and a maximum of 10 cuts in the area. Okay. All right. Let's go to sorting. It's going to be a zigzag, and it's going to start from the leading edge. That means my tool will start cutting from the leading edge side. So that's what it means. And the ordering, we have got about 4 types of ordering. First type of ordering is it will start from this face and it will go up to this face. So that we call it left to right. Or it could start from this face and end up on this face. That's called right to left. And then you have got another method which starts from the center and goes away to either of the faces, either in climb milling or conventional. So those are the other 2 options that we have in ordering. I'm going to use the default left to right, so I'm going to start from this blade and end up on this blade. Edges, I'd like to keep that automatic. In the tool axis control, you can see that we have very less parameters to work with. What we have new in SolidCAM 2014 SP2 is that earlier we just had one limit angle. Now we have got both the limits, minimum and maximum, so as to take care of machines which can't tilt too much. But Hermle, we don't have an issue because it goes plus minus 110, so it's pretty big range that we have. Otherwise, we could control our limits out here. Okay. Link, again, is automatic. You can see in application-specific module of SolidCAM, almost everything is automized. That means here the user intervention is kept to bare minimum. Count check only when we need it. All right, so we already have everything. So I'm going to save this and run the calculation. The calculation is done. Okay, so let's see the results. That's nice. So you can see that there are no rubbing happening on the trailing edge side, basically because the cuts are distributed according to this particular surface, the edge of the surface. So we don't have the rubbing happening. So let's run the simulation. Let's go to the Solid Verify, and then we'll also see machine simulation. Okay, this is our initial stock. We can start. Nope. Okay, this is how our roughing of 5-axis impeller would look like. Now, since we do have some material left over on the blades, let's also look at some of the finishing options that we have inside multi-blade machining. Right, so let's switch off the toolpath and add multi-blade, blade finishing. So we have got roughing, blade finishing, hub finishing, and fillet finishing. So let's put on the blade finishing. Here we're going to use hub and shroud. So let's pick up the surfaces first. Let's check if this is the blade now. So we'll use the browse button and pick the relevant surface for our cutting. Okay, so we're going to pick face 3, and the hub basically is face 1. It doesn't matter where your blade is and where your hub is, as long as these are surface of revolution. It doesn't matter if your blade is here and the hub is there. SolidCAM will understand what you're trying to do because it's an application-specific module, so it will prepare the surfaces internally in such a way that it can be machined. And my shroud, okay, we can pick all of them, although one is good enough. Right, so we'll use another taper ball nose in this case. We're going to use a slightly longer one for our roughing. Okay, let's select this. Levels, automatic. Technology, we're going to trim the cuts at the trailing edge. You're going to have about 15 numbers of cuts, and we'll start at 2%. Why we are putting the start value is, when we have this edge, this looks a very nice edge to us, but internally this edge could have, it could not be a straight homogeneous edge. It could have a lot of saw-like appearance, the saw teeth appearance. So in such cases, the toolpath, quality of the toolpath is not good because we'll have retracts. To avoid that, we start our cuts about 2% below this particular edge so that we get a nice cut. Okay, let's go to sorting. It's one way. We're going to start from the trailing edge. Okay, everything else, again, like I said, is default, works automatic. Let's save it and run the calculation. The calculations also for multi-blades are very fast. You can look at that. My toolpath is already calculated. You can look at the quality of the toolpath. Very nice and smooth. So it's doing a pretty neat job when generating the toolpath. Okay. Let's also see some finishing operations for the splitter. Let me not edit, just save and pick the splitter. Let's see which is a splitter here. Okay, this is a splitter. The other hub and shroud are going to remain default. The tool is going to remain default. The parameters are going to remain default. In fact, we can add, let's say, 18 cuts on the surface, and let's hit save and calculate. The calculations, like I said, in this application-specific function, they are very, very fast. That's the calculated toolpath for machining the splitter. Let's also quickly add the hub finishing. So I'll use hub finishing, blade splitters, it's that, just to confirm, yes. And the hub surface is that one. Okay. Let's pick the tool. Not that. That's tool number 4. Okay, in the technology, let's say I want a maximum of 0.5. That's a step over between two passes. It's bidirectional, starting from the leading edge. Okay, let's save and hit calculate button. Right, that's also done. You can look at the calculated toolpath. Now what we could do is we could see the first two toolpaths in our machine simulation. For that, let me just change the settings to include the solid or the stock. So let me simulate the machine simulation. Okay, you can see that we have reached the machine limits for one of the toolpaths. So it's giving me a message saying that A-axis has gone beyond 115 degrees, where our minimum maximum was about plus 30 and minus 115. Let's ignore this error. As I told you, these can be changed, or this can be taken care of in the limits page in Multiblade. Right, so there is my part. Let me switch off the toolpath. So you have the part. I have the stock, so I'm going to switch off the part. And let's run the simulation. Increase the speed. Assuming that now I want to move to my next toolpath, having seen some of the 3D machining, I can just select the next one immediately. What SolidCAM does is it internally starts updating the stock that otherwise would have taken a bit longer time. It does it much faster. It's going to take a maximum of about 45 seconds, out of which we have already elapsed 17. And then it uses the updated stock to show us the simulation of the next process. Okay, let's run this simulation. Sorry, the machine simulation. What it did at a fraction of a second, I don't think you'd have observed this. It calculated the first stock of iMachining 3D, and then it's going to send the stock to the machine simulation. Okay, let's see. You can look that we now don't have much of an issue because we have controlled the minimum and maximum angles that our toolpath can take. We can start the cutting. That's much fast, so I'm going to cut down on the speed. That's how it's going to go. We can increase the speed, no problem. After about a few passes, I'm going to stop it to show you how the machining looks like. Controlling the limit is actually very easy inside SolidCAM. Even in the regular generic 5-axis engine, controlling limits is very, very easy. I've seen users basically break their head when they get into limits because then they have to depend on the post-processor to bail them out. But here, while calculating itself, we take care of the limit, so we don't have any issues with post-processing afterwards. Okay, let's cut down on the speed, and here we can see slowly. That's how it's cutting. Let's stop it. We've seen. What do we offer here in our simulation? We offer a lot of things. First of all, I can go into my analysis and I can run a deviation that's between the stock at any given point of time. So it's dynamic. At any given point of time, I can stop my machine simulation and I can run a deviation analysis between the part geometry and the stock. You can look at the deviation analysis straight away. So what it is showing us now is it's showing us different bands of color, and I can zoom in into a particular position. Now I would like to find out what is the material remaining on this particular area out here. Okay, so let me just remove all of them. So I can just hover my mouse to a point where I want to see and select the middle mouse button. So immediately tells me what's the deviation. The deviation at this point is about 0.06. So I can check. For example, I can go out and I would like to check what is the deviation probably in this scallop up here. So I'll select that. That deviation here is about 0.17. That's because of the scallop. We have a higher deviation. So you can do a lot of things. You can check on the deviation. Let's remove all of them. You can also check in the analysis, you can check the tool number. Okay, now it's very clear. The orange one is basically done by the first tool, and the second one is color is done by tool number 17. Now you could also change, you could also check the orientation change. Where did you have maximum orientation change between angles? So a lot of things can be checked. Okay, also check height change. So it tells me the difference in height, maximum of 0.4 and minimum of -0.4. Right, you can also check on the deviation. So a lot of things of this kind can be done, a lot of analysis of this kind can be done from the machine simulation apart from looking at the simulation itself. All right, let's come out. So we have our toolpath. We saw iMachining 3D, we saw roughing, and we also saw some finishing strategies of Multiblade on how to cut this part. Although this is not a very popular method, but this method is catching up very quickly because of iMachining, because of its ability to knock out volume of material much faster in some cases much faster than turning. So a lot of customers now have moved on to iMachining to knock out volumes. Now, whether this could have been machined this way or not, let's see a small cutting movie. Okay. Okay, that was a small glimpse of a movie. I don't know if it was very clear to everyone, but this particular movie is available on YouTube for you to have a look at. So basically, we are at the end of our webinar. It was a short one this time. If there are questions, I'll be more than glad to answer. There's already one question. How do you change the default stock value in the stock area? I don't know what does that mean. But let's run into the definition, and I don't know what is the default stock value. You mean to say if these values can be changed? They can be changed, but they have to be changed inside the system. You can't set a value outside the system in some settings or something to change the default values. Okay, any other questions? You could just type your questions, and I'll be more than glad if I have. Of course, there's somebody who's raised their hand. Mr. Anatoly, if there's a question, could you just type the question in the chat area? I'll have a look at it. Okay, I don't see questions panel. I don't see any more questions coming up. Aya, would you like to wrap this up?
Okay, Amon, thank you. If anyone wants to watch this webinar again or any of the previous webinars, then of course we will upload this today or tomorrow, and the rest of the webinars are already in our website, so you are more than welcome to watch them. Thank you very much for attending, and I hope we will see you next week too. Have a nice week.